All right, welcome to day 3 of the picture lab. We're going to do two mirroring image methods today, two methods that mirror an image. The first one will copy all the pixels from the left over to the right. So we'll start in column 0, copy everything from column 0 over to the last column. All right, so within the picture tester class as usual, create a void method. Remember, it's got to be static because the main's going to call it. The main static, so the main cannot call non-static methods. It's called vertical mirror. And receives no parameters. There's our signature. And the first 1, 2, 3 bullets, actually 4 bullets here, are fundamental code we saw in lab day 2 and also in last night's homework, the reminder. So the usual first 4 bullets here. It says to use red motorcycle. Display the picture. Create the 2D pixel array. Pixel array. So type pixel. Actually, two-dimensional array. And what do they all usually? They usually call it pixels, don't they? P-I-X-E-L-S. Now, what in the heck is the name of that method? If it's tomorrow's quiz and you're trying to remember, is it get 2D pixels, or what in the heck do they call that dumb thing? Well, on tomorrow's quiz, you'll have the quick reference, and it's on there a couple places. So there's no way you're going to spell it wrong. Okay, so get pixels 2D. Good? I think that's right. I'll go ahead and put a brace there and close it and compile it, make sure I'm okay so far. All good. All right, now we set up 2 nested traditional for loops. If I've got directions tomorrow like this, don't disobey the directions. Don't do your own quiz question, do Mr. Reiske's quiz question. Traditional for loops. I'm not broadcasting. I'm funny. Okay. Sorry. You can yell next time. No problem. Okay, the outside loop goes through the rows. Inside loop goes through the columns. Name of our matrix is pixels. Let the inner call loop only halfway through the columns. So divide the length by 2, the number of columns by 2. Okay, now get a little bit of flexibility here. It says store each pixel's row call pixel in its appropriate mirror image position. We're going to take a left pixel and store that pixel in a right position of the matrix. I was going to say store its RGB values, but that's really all a pixel is. So you could just say store the pixel. So where's the left pixel at? pixels of row call. That's what we're looking at now. Where is the right pixel? Well, if we're just starting out in row 0, column 0, it'll be the same row across the screen to very edge. The very edge is the last column. How many columns are there? Well, for some kids this morning in earlier classes, it helped them if they found the number of columns up front, like this. And so, where is the last column? Numcals -1. And that's okay for the first time through. When you want to exchange with column 0 to the last column, this works. But when you go next time to column 1, right, with column ++, this is still the last column. So you want another less column, or just subtract the column we're in right now. So subtract the value of the left column and you'll have it. We've seen that algebra before. Okay. And so we want to set the color of the far right pixel to the color of the left pixel. So right dot set color left dot get color. Again, if I didn't know that tomorrow on the quiz, if I didn't know if it was called color or set color or fine color, I go in the quick reference in the pixel class and set color and get color. Now, I don't know. I guess that's what you want to do. Let's close these braces, see if it works. Then we'll take a look at the College Board solution. Does it look good to you? Does it look all right? Kinda. This is called vertical mirror. You got to call it from the main. Did I forget something? Let's see. Probably some braces. No, compiles. Red motorcycle. Did I do it right? Yeah, I did. Okay, good. All right. Anytime there's math, like -1 minus call, it's not something guaranteed even for Mr. Reisky. It's tough, okay? Okay. Again, it doesn't matter if you don't divide by 2. If you go through all the columns, it still works because by the time you get past the middle, they're all the same. It'll still work. It's just you're wasting your computer's time. And that's very important, of course, in the real world where there's certain programs that might run 24/7. Split seconds of programs that run 24/7 add up and add up and add up to something very undesirable. Let's take a look at how the book did it. Okay. Okay. The biggest eye opener here, probably. Ready? The biggest eye opener here is certainly, compared to mine at least, they used the crazy word null. Oh my. We saw null 2 Fridays ago for the first time and only time this year. I've not really gotten into it much. We had a matrix of students that day. The matrix was a seating chart. And just like in this class, there's empty seats. So anyway, If you declare your pixels outside the loop before the loop starts, you might want to make them null to begin with. You could make them, what, pixels of 0, 0, I guess, whatever. But they chose to make it null.